In this video, we will be looking at radicals. By the end of this lesson, you should be able to express the square roots and cube roots of whole numbers and the square root of a monomial algebraic expression in simplest radical form. So let's take a look at what a radical looks like. We may have seen this before. We have our radical, which is the symbol here. That is your radical symbol. We have this shape right here. That's what we call the radical. We also have the index or the root, which is the tiny number that's outside of my radical. For square roots, we won't have anything here. Okay, so sometimes there'll be number there and sometimes there won't. But we call it the index or the root. And then inside our radical is called the radicand. Whatever is inside the radical we call the radicand. If we recall what a radical means, we go back to the idea of exponents. If we recall 2 times 2, I can write as 2 squared. I have 2 of them. 2 squared is equal to 4. We use radicals, we want to travel in the other direction. The square root of 4 is equal to 2. And notice that I did not put a number in there. For square roots, we do not write the index or the root. If you see another number there, we'll look at more examples of that during this lesson. So the square root of 4 is 2, meaning 2 times 2 gives me 4. Just like 4 here is a perfect square, we have other perfect squares. If you notice on the side of your notes, we have a list of perfect squares. Numbers that when multiplied by themselves, we get this nice list here. You don't have to memorize all of them. It's helpful to know them as we go forward, but this is a list up to 15 that you can use for reference. So when we're simplifying radicals, we want to have the radicand have no perfect square factors other than 1. So remember the radicand is the number under the square root. We want it to have no perfect square factors other than 1. So let's look at simplifying these examples. We want to write them in simplest form. So if I look at number 1, I have the square root of 24. I want to use my perfect square list. So I'm going to start and find where 24 would fall on my list of perfect squares. And I see it would be between 16 and 25. So what I want to do is start by dividing 24, my radicand, by 16. So I'm going to go over to my calculator and do my 24 divided by 16. I don't get a whole number, so I'm going to try my next number on my list as I move up. So 16 didn't work, I'm going to try 9. 24 divided by 9, well, I know that's not going to work either. So let's try my next one. I have my 4 here, so I'm going to do 24 divided by 4. And that one does work. 24 divided by 4 is 6. So I'm going to rewrite the square root of 24 as the square root of 4 times the square root of 6. And I know that the square root of 4 is 2. 2 times 2 gives me 4. So I have 2, and then I have left over the square root of 6. I always want to check to see if my radicand can be divided by any of my perfect squares. And I know that 6 cannot be divided by any of the numbers on this list, so it must be in simplest form. Lastly, you can check to make sure that your values are equal. I can type into my calculator the square root of 24, and then my simpler version that I just found, 2 square root of 6, and I should get the same decimal, meaning they are equal in value. One is just in simpler form. Let's take a look at another example. We're going to look at number 3. We still want to get this radical in simplest form, but if you notice, I also have some variables here. So let's first take a look at my number. So I'm going to just look at root 27, the square root of 27 by itself. I'm going to simplify that just like we did in the last example. I notice that 27 falls between 5 squared and 6 squared, 25 and 36. So I'm going to start right here. So 27 divided by 25 does not work. My next one is 16. 27 divided by 16. I don't get a whole number there. My next number is 9. 27 divided by 9. And there we go. 27 divided by 9 is 3. So I can divide 27 by the perfect square of 9. So I can rewrite the square root of 27 as the square root of 9 times the square root of 3. I know that the square root of 9 is 3. And I have left over here the square root of 3. And 3 cannot be divided by any of the perfect squares on my list. So I have my square root of 27 simplified. Next, I'm going to take a look at my variables. I'm going to take a look at x to the 5th. Recall that x to the 5th can be written as x times x times x times x times x. I have 5 of them. When I want to take the square root, we are looking for pairs. Just like we had our 2 times 2 gave us 4, for the square root, we're looking for pairs. So here I'm going to circle all of the pairs of x's that I see. I have a pair of x's here. For every one pair of x's, I'm going to write an x on the outside. So one pair of x, I can pull one out. Another pair, I have another x. And I have this one that's left over. X times x is the same as x squared. And I have left over my square root of x. I check to make sure there are no pairs left, and that is as simple as my x's can get. I'm going to do the same thing with my y's. The square root of y to the 3rd is the same as the square root of y times y times y, 3 of the y's. Again, I'm looking for pairs. I see I have a pair of y's, meaning I can write one y. And I have one y left over. So that is my square root of y to the 3rd simplified. My last step is going to be combining all of it together. So I look at everything that's on the outside of my simplest forms, and I'm going to put all of those together. 3x squared and y. And then under the radical, I have all of the numbers and variables that fell under the radical. 3xy. And then before I say this is my final answer, I check to make sure I have no pairs, and my number here cannot be divided by any of my perfect squares, and they cannot, so that is my radical in simplest form. Next, let's take a look at cube roots. Cube roots is going to follow the same pattern, except we have to remember how cube roots are different. So here, the radicand has no perfect cube factors other than 1. So we're going to write all of these radicals in simplest form. Let's take a look at number 5, the cube root of 24. We're going to follow the same process, except we're going to use our list of perfect cubes. If we recall here, 2 to the 3rd is the same as 2 times 2 times 2, which gives me 8. So the cube root is the same idea as the square root, it goes the other way. The cube root of 8 will be 2. 2 times 2 times 2 gives me that 8. So here when I'm looking at simplifying the cube root of 24, I do the same thing. I find where it would fall on my list. It would fall between 8 and 27. So I'm going to type in my calculator, 24 divided by 8, and I get 3. So I can break this up into the cube root of 8 times the cube root of 3. Good. And I know that the cube root of 8 is 2. And I have the cube root of 3 left over. So now I've simplified the cube root of 24 to be 2 times the cube root of 3. Always check to make sure this number cannot be divided by any numbers on my list, and it can't. Again, we can check using our calculator. I can type the cube root. Remember, if I go to math, number 4 is my cube root button. The cube root of 24 gives me this decimal. And if I look at my simplified version, 2 times the cube root of 3, 2, I hit math again. Number 4 times the cube root of 3, and I get the same value. It is the simplified version. So that is cube root of 24 in simplest form. Let's take a look at one more example. Let's take a look at number 7. So I'm going to do the same thing as I did with my square root with exponents. I have the cube root of 27 I'm going to look at by itself. The cube root of 27 is actually a perfect cube. It's on my list. I know the cube root of 27 is going to be 3. Next, I'm going to look at my variables. I have x to the 5th, so I want to find the cube root of x to the 5th. I can write that similarly as I did before. X to the 5th is x times x times x times x times x. Notice that I'm writing my cube root each time though. When I had the square root, I didn't write a number, but a cube root, I want to make sure I write that 3. Now here, the one difference is we want to have, as we notice here, 3 2's made my 2 to the 3rd equals 8. So here I want to look for sets of 3 instead of sets of 2. So I have my set of 3 here, which means I can pull out an x. And I have these 2 x's left over. So I have x squared left. It's okay to have x squared there. I'm looking for sets of 3. So that's the cube root of x to the 5th in simplest form. Last, I want to look at my y's. I have the cube root of y to the 3rd. I can rewrite that as the cube root of y times y times y. And remember, I want to pull out groups of 3. So I see I have one group of 3. That means I can pull out one y. I have nothing left over for this one. My last step, I want to put it all together. So I take everything on the outside together. I have 3xy, and then everything that's on the inside of my radical, which for this case is just the x squared. So I have the cube root of x squared. And I check to make sure I have nothing on my list or no groups of 3 under my radical, and I do. So that is my simplest form of this radical. Please make sure you bring your notes to class. We will continue to practice this and work on it together.